that moment when a random thought becomes a research idea? This is where my manuscript journey begins. Now, I'm not just reading everything. I'm narrowing it down to the papers that answer my real research question. After sorting all these papers, my vague idea has become one clear, focused research question. Now I have my research question. I need a simple, practical study design that I can actually do. In my mind, I can already see the patients I'll include and the data I need to collect from each one. Every study lives or dies by its variables. I must choose only the ones that truly answer my research question. Now my research question, study design, and key variables are clear. I finally have a simple protocol I can submit. Before stats, I must be clear. What exactly am I measuring in this study? Some variables describe my participants, some are exposures, and one is my main outcome. The outcome depends on something. That something becomes my independent variable.
Once my variables are defined properly, choosing the right statistical test becomes much easier.
Once my variables are defined properly, choosing the right statistical test becomes much easier. The outcome depends on something. That something becomes my independent variable. Some variables are categories, and some are numbers we measure, and both are important in healthcare research.
Blood group is nominal, but a pain scale from 0 to 10 is an ordinal variable.
Patient count is discrete, but blood pressure is continuous because it can take many possible values. Knowing if a variable is nominal, ordinal, discrete, or continuous guides me toward the right statistical test. T-test, chi-square, ANOVA, correlation, so many tests. How do I choose the right one? First, I check my outcome variable. Am I measuring numbers or just categories? Two categories versus a mean, or two numbers together, each pattern points to a different test. Now, I'm not scared of test names. I follow my variable types like a roadmap. In the ward, I keep seeing yes or no outcomes. Perfect for a chi-square test. Chi-square just checks if these categories differ more than we would expect by chance. My data go into this simple table, not directly into a scary formula. Here I have two groups, and I want to compare their average values.
The t-test asks whether the gap between these means is bigger than random noise. For continuous outcomes like blood pressure, a t-test is often the first simple choice.
Statistics feel friendlier when I remember that every test is just a structured comparison. Every test is just a structured comparison. Correlation simply tells me whether two continuous variables move together. A scatter plot makes correlation visible as a pattern of dots and a line. Upward dots mean positive correlation. Downward dots mean negative correlation. Even a strong correlation does not automatically prove cause and effect. Regression takes correlation one step further and lets me predict an outcome from a predictor.
With regression, I can adjust for a second variable, instead of pretending it does not exist.
I focus on the coefficient, its confidence interval, and the p-value, not every tiny detail.
Regression is just a tool to summarize relationships. Clinical sense still comes first.
A small p-value means my data would be rare if the null hypothesis were really true. P-values talk about surprise, Effect size tells me how big and meaningful the difference is. A confidence interval shows a range of plausible values, not just a single magic number. For my manuscript, I report the effect size and confidence interval, not only whether p is less than 0.05. Before any test, I must scan my dataset for missing values and strange entries. If a value looks extreme, I check whether it is a real patient or just a data entry mistake.
I arrange my columns so that IDs, exposures, outcomes, and timings follow a consistent order.
Clean data makes every analysis more trustworthy and much easier to defend in a Viva or review.
If group spreads are very different, I consider whether my chosen test can handle that.
I ask whether my observations are independent or repeated on the same patient over time. If assumptions are not met, I adjust my plan instead of forcing a wrong statistical test. Table 1 should describe who my participants are before any hypothesis testing starts. For continuous variables, I present both a central value and a measure of spread.
For categorical variables, I show both counts and percentages, not just one or the other.
A good descriptive table lets readers picture my sample even without seeing the raw data. I pick bar, line, or box plots based on what I want the reader to notice first. I avoid 3D and decoration. Simple, clear figures are kinder to busy readers. For repeated follow-up, a line graph often shows trends better than a crowded table. My figures are there to support the results section, not to compete with it for attention.
Good results translate tables into clear sentences without repeating every single number.
I report the effect size and its confidence interval, not only that p is less than 0.05.
A result can be statistically significant yet clinically trivial, so I comment on both aspects. My goal is a results section that is honest, precise, and easy for colleagues to understand. Before submission, I read my analysis plan again to be sure I followed it honestly.
Talent. When reviewers question my statistics, I treat it as a chance to strengthen the manuscript.
If needed, I rerun analyses, update tables, and clearly explain any changes in my response. Now my analysis is transparent, consistent, and ready to face editors, reviewers, and examiners.
I avoid running many unplanned tests just to find one small p-value.
If I test too many things, I risk false positives, so I focus on my main outcomes. I always check what denominator I am using when I report proportions or rates. In the long run, transparent methods protect my reputation more than any statistical tricks. A modest sample size is not a shameful secret. It belongs honestly in the limitations. Because my data come from one center, I clearly say that generalizability may be limited. In an observational study, I admit that unmeasured confounders might still influence the results. A good limitations section is honest about weaknesses without destroying the value of the work. For my slides, I convert heavy tables into simple visuals that tell the same story. I choose one clear figure for each key result instead of flooding the audience. I rehearse explaining my statistics in plain language, as if to an intelligent friend. When I understand my own analysis, I am not afraid of Viva or audience questions. When I understand my own analysis, I am not afraid of Viva or audience questions. I wish I had learned statistics this way earlier. So I'm sharing it with my juniors now. I upload my learning resources so that others can avoid the fear I once had. From confusion about variables to a complete manuscript, this journey was worth the effort. If I can learn research statistics step by step, you can too. And your manuscript deserves it. When Turnitin shows a scary similarity blob, my heart rate shows a spike too. Then I remember, pasting whole paragraphs is not taking notes, it's plagiarism. Paraphrasing properly and citing the source. Slowly, the similarity ghost becomes tiny. Some nights I drink so much coffee that even my syntax forgets what it's doing. Pro tip: never run a t-test on the coffee consumption column by accident. When every output looks funny, it's not the software. It's just time to sleep. I swear I started early, but somehow the deadline always finds me at midnight. Imagine emailing the journal a cartoon instead of your results. Almost did that once. That tiny submission successful tick feels more powerful than my morning coffee. Past me thought VAR 1 and VAR 2 were fine. Present me strongly disagrees. Renaming variables once takes time, but it saves hours of future confusion. Future me is always grateful when present me keeps the dataset tidy. There is no horror movie jump scare like decision email received from a journal. Reviewer 2 is often kind, and reviewer 1, well, keeps my ego in check.
Once I highlight each point calmly, even reviewer 1 becomes manageable.
Sometimes I forget the easiest formula, right in the middle of a Viva practice. I pretend the software is listening while I complain. Then I finally read the error. Sometimes the best solution is to step away, walk a little, and let my brain reboot.
We stand upon the edge of what's to come.